Okay, let's start. Today we are going to do the first project, the first week of the first project. Okay, so this project will continue to do like for the next 2 weeks. So 3 weeks project, right? So the first week we will be focusing on visual tracking. Okay, that is because for the next 2 weeks you are going to do experiments. You are going to do experiments using the mobile robot and based on the image projection, image observation of the ceiling cameras and also the onboard camera. Okay, for the onboard camera is eye in hand control. For the ceiling camera is eye to hand control. Right. So you need to. The first thing you need to do today is to do visual tracking. That is, you need to know how to write program to access the images, the real-time images obtained, grasped from the camera, onboard camera, and also the ceiling camera, both. Okay, you need to do that. Okay, grasp the real-time images sequences. Okay, and then you need to process the images for the feature. For this purpose, you probably will need to track the square of a square pattern. Okay, to grasp. Determine the corner points in order for the control illustrated in the figure in this project notes. All right. Okay. So today only visual tracking. For the next 2 weeks will be eye in hand, eye to hand control, real-time control of the mobile robot. Okay, based on the real-time observed image features. Okay. So today it should be simple and straightforward today. Okay. I will give some very basic introduction for you to understand what to do today. Okay, so today you are going to use certainly the desktop PC, but not only the cameras on board the mobile robots and also the ceiling cameras. Okay, and for image processing, some basic information and background information you should already know, right? Okay, so for example, you obtain the color images from both cameras, right? And so you need to do the transformation from RGB to gray level value, right? It's basically we use the the standard one, that is the average value of RGB to be the gray level of that pixel, okay, each pixel. And once you set up some thresholding value like this I, like this T, okay, then you can separate. You can do this classification, gray level classification, by either 0 or 255, either black or white, right? Okay, so once you obtain this gray level image, you might set up some thresholding to separate into only two value, black or white. Okay, that is called thresholding. You probably need to do this, okay? And the way we do this for given images from left to right and then top to bottom, follow this order to process the whole image frame, right? And then by using this processing, okay, then probably you can transform this color image from the left to the black-white image here, all right, like this, based on the binary classification. Okay, and you also need to. Some of you may already know this some basic image processing techniques like erosion, dilation. Okay, but if you don't know, you just learn today. Okay, you need to know this, or you can also do select some other ways to perform corner detection of the feature. It's okay too. Okay, and for erosion, erosion is like you select the minimum value among the pixels. For example, if you perform 3 by 3 mask here, like this one, you mask this 3 by 3, 9 pixels. You perform erosion function. That means you perform the minimization of the 9 entries here around these center pixels. So because these are white and only this is black, right? So only this 0 is the minimum value. So you select 0 to replace the middle pixel here. So middle pixel, the value of middle pixel becomes 0. Okay? If you perform dilation among this around this center pixel here, so you need to select the maximum value among these 9 pixels. So that is 255, the white value, right? So you will replace the middle pixel by white, that is 255. So you perform this from left to right and the top to bottom, following this order to process the whole images. Okay. And like this, you around this center pixel from left to right, top to bottom, given a mask. Like for this example, this is 5 by 5 mask, all right? And you can see these examples here. And closing and opening further, like dilation and distortion, or the other way around. Okay, further processing. Okay, you can refer to the sample here. One thing I want you to know is about the border handling. Okay, when you process the images. Okay, for example, here, if you perform like this, is perform the dilation, like dilation from the left to right, top row to bottom row. For example, when you process the first pixel here, you need to max. For example, you perform 3 by 3 mask here, okay? But obviously 1, 2, 3, 4, 5. These 5 pixels are missing, right? So you just ignore this. You only compare between these 4 for this mask, okay? So all pixels beyond the images are ignored, okay? Remember, you have to correct your program like this, okay? When you process the border parts, border pixels. Another thing I want you to know, and perhaps some of you already know, okay? But if you don't know, just learn it. Like, it's called perspective projection, like also perspective transformation. That is the model of a camera, okay? Model camera. It's very simple, based on the geometry, okay? So it's like if you have a camera here, that this is the image plane, okay? And this is the frame of the camera, the three-dimensional frame of this camera. And the P here is a 3D point. So in order to determine the image coordinates of this 3D point, you need to draw a line from this point, 3D point, to the center of the image, center of the optical center of the camera, right? And the intersecting point between this line and also the image plane is the image projection of this 3D point, right? Okay. So following this very simple geometry, similar triangle, okay, you can see that this U compared with the focal length F is equal to this X compared with the depth Z, okay? Similarly, along the Y direction, horizontal direction, the V over F is equal to Y over Z. So you have these two equations in number 8, okay? So following this, you can have the perspective projection model, okay? It's very easy. If you don't know, try to figure out. If you still cannot figure out, ask me, right? Okay? Okay, that's the basic background you need to know today, okay? For the mobile robot kinematics, I will give some introduction next week, because you only need to do that next week. And but before you come here next week, maybe you can follow these notes to read in advance. That is better, okay? So, but for today's task projects, okay, what you need to do. Okay, you can see here. So today's first week is to you need to write program to grasp real-time image from both cameras, and then you need to try to grasp the particular feature of the pattern in front of you, like the square. You need to determine the corner points, okay? Track the corner points. So when you track the corner points, the simplest way you do is you process each image separately, kind of continuously. But actually, if you do this, this very simplest way, right? So if you do this, you have to process the whole image every time, right? The computation is a lot. But you just do that. It's okay for this course. But I want you to know that if you want to speed up your processing in the future in your experiments, you need to raise the sampling rate, the processing rate. What you can do is like window-based processing. It's like if you want to track, give me the pattern. The pattern. You need to track the pattern, right? The square. Is that? So they don't need this today? They need this, right? So you have to prepare, right? So for example, you want to track the corner points of the square here, okay? Either the red square or the blue square. So the image, for example, if this is the whole image plane, projecting image, and this is only some part on the image, right? On the image. So the simplest way is to process the whole images to determine this square and determine its corner points. But if you want to speed up the processing in the future, you can try to, when you first process the images, you find out this square, and then you, based on the center of this square, you have a smaller window here, okay? And then you only process pixels within the window for the next coming images. So for the next image, this square might move, right? But might still within this small windows, and you only process a small window to find out this square, and then you update the position of this window, this square within this small window, and then you can update to the whole window, the position in the whole window, right? Window frame. The main thing is that the size of this window certainly depends on the moving speed of this pattern, right? If you move very fast, certainly the window must be larger. If you move slow, the window can be smaller. If the window is smaller, the processing rate can be higher, okay? But you need to do the transformation between the small window and the large window. You need to keep updating the small window. When the square moves, you need to update the new position of the window centering around this square, okay? That's the basic concept, the window-based tracking, okay? But you are not asked to do that today, okay? You only need to do the processing of the whole window every time you grasp new images. Understand? Okay, that's easier, okay? But if you have time, you are very good in programming, you can do that, okay? But if you do that, let me know, right? You can have extra credits. All right, so this is basically what you need to do today. And so you need to connect both cameras. Make sure you can connect to both cameras first and know how to grasp real-time images. And then you need to check the image transmission to make sure it's okay. And you need to do further detection for each glass camera to determine the feature you need, like the corner points, position, that is the coordinates of the corners on images, okay? That's the first week you need to do. So looks like it's not a big trouble, right? Should be okay for you. And then let me know what else. TA will tell you how to do this programming right after my talk. And anything TA want me to tell students? TA? Anything? Okay. Also, I want to know first about all the students sitting here today, because on the school official list, they are 25. They are 25 for now. But how many students are here today? How many students are here today? 20, 22, 21st, 21. Okay, so stay with current stay with your current teammates. Okay, if 21, all of you are already assigned with a particular team, right? Okay, so if there are more students joining us, we will add to existing teams, all right? But for now, just keep it. Okay, maintain this team. Okay, maintain your team first. And when you submit your report, but not next week. Okay, we only submit experimental project report after you complete the whole project. Like for this one, the project one, you have 3 weeks, right? 3 weeks project. So only after you finish the 3 weeks project, after that, like 1 week later, you submit report. They will listen to TA's assignment, okay? And then only one team, one report, okay? But on the first page, you need to fill out all the team members and confirm the contribution percentage of each member, right? That's fair, right? Okay. Okay, so now I will ask TA to introduce how you can do the programming for what you need to do today, okay? Let's start.